Friends, in this video, we will solve one problem based on the calculation of the time and the energy loss in transient operation. Let's begin. Friends, this will be the very important problem in concern with the university examination point of view, because in university examination such type of question may be asked for 5 marks. That is the basic problem to calculate the value of the time of reversal, that is finding out the value of the t in university examination. Okay, so we will start to discuss about the problem. What will be the problem? So a drive has a following parameters. So it is a electrical drive. The drive system employed for motion control, it is called as drive. If we are using a electrical motor for motion control, then it is called as electrical drive. So in given problem, we are having one drive. So drive has the following parameters. So as we know that there are different parameters of drives. First parameter is J, that is polar moment of inertia. Second parameter is motor torque Tm. Third parameter is TL, that is load torque, and the fourth parameter is called as the angular velocity. So in the given problem, we are having the value of J. So the value of J is 10 kg meter square. The value of T, that is called as motor torque, that is 100 minus zero point 0.1 N Newton meter. The value of the passive load torque is the TL, that is the value of load torque is 0.05 N Newton meter, where this N is called as the speed in RPM. So we are getting the value of motor torque as well as load torque in terms of the speed. Okay, so the value of that particular speed is very important in solving that problem. So the drive initially operating in a steady state, that time obviously the motor torque is equal to load torque. This will be the condition for the initial state. Now it is to be reverse. So after steady state operation, the transient state will occur. Means the direction of this drive is now reverse. So for the direction of reverse, the motor characteristics is changed. Now the motor torque, that is Tm, for reversing operation, now it will be changed. So the direction of that particular motor torque is reverse. So it will shown by the minus sign, that is minus 100 minus zero point 0.1 N Newton meter. Again this N in terms of speed. So we want to calculate the time of reversal of a such drive. Okay, so this will be the actual problem for your understanding. I think everyone has got the basic concept of the problem. So again I can repeat this problem. A drive has a following parameters: J is equal to 10 kg meter square, T is equal to 100 minus zero point 0.1 N Newton meter. Passive load torque, we are having the TL is equal to 0.05 N Newton meter, where N is speed in RPM. Initially the drive is operating in steady state. Now it is to be reverse. So for that the motor characteristics is changed to T is equal to minus 100 minus zero point 0.1 N Newton meter. So at that time we want to calculate the value of the time of reversal. Okay, so friends, let's first of all we can understand the given data of your problem. So in a given data we basically have the value of the moment of inertia. So the indication of the moment of inertia is called as J. The value of moment of inertia is 10 kg meter square. Then the second parameter of the given data is called as the steady state motor torque. The value of the steady state motor torque is equal to 100 minus 0.1 N Newton meter. So what do you mean by N? That will be the N is the speed in RPM that we have given in the problem. The third given data in the problem is called as the steady state passive load torque. and we have the value of the steady state passive load torque is 0.005 N Newton meter. So in the passive load torque, the value of N is also called as the speed in RPM. Okay. Then the next given data of your problem is called as the motor characteristics when the motor in a reversal field. So that time the motor torque when the speed is reverse. So that time of the motor torque is called as minus 100 minus zero point 0.1 N Newton meter, where N is called as the speed in RPM. So this will be the given data of your problem. So now from that particular problem we want to find out the value of the first, that is the steady state speed. So the value of the steady state speed is called as n1, that we want to find out. Then the second thing that we want to find out the value of the final reversal of the speed. So the final reversal of the speed is called as n2, so that we want to find out. And the third very important thing that we want to find out, that is called as the time of reversal. So this will be the problem. So in the problem we have the value of the J, that is polar moment of inertia, the steady state motor torque, that is called as Tm, the steady state passive load torque, the passive load torque is called as the 0.005 N Newton meter, and we have the motor characteristics when the reversal of speed. So the motor torque, now it will be reversed, so that will be indicate the minus sign, that is minus 100 minus zero point 0.1 N Newton meter. So from that we want to find out first thing, that is to find out the value of the N1, that is steady state speed. Second thing that we want to find out the value of the final reversal of speed, that is called as N2. Okay, and the third that we want to find out, that is called as the time of reversal. So friends, we will start to solve the problem. So the next step, so in that particular step that we want to find out the value of the solution. So this will be the solution of your problem. So for the solution of problem, first of all we can get the fundamental torque equation. So for the steady state speed we have the fundamental formula, that is the fundamental formula for the steady state, that is motor torque is equal to the load torque. So we are getting a fundamental equation, that is Tm minus TL is equal to 0. So in the given problem we have the value of the Tm. So what will be the value of the Tm? That we are having the value, that is 100 minus zero point 0.1 N, where N is called as speed in RPM, and we have the value of the load torque. The value of the load torque is what? 0.005 N is equal to 0. So that will be the equation that we are having, this equation here, that is 100 minus zero point 0.1 N minus 0.005 N is equal to 0. So this is from the fundamental equation, that is for the steady state characteristics or steady state speed. Okay, so now we are converting this equation into 100 minus 0.15 N is equal to 0. So from that particular equation we can get the value of, that is obviously the value, that is minus 50 N is equal to minus 100. So minus minus sign get cancel. So we are get value, that is N is equal to 100 divided by, that is 0.15. So we are getting the value of speed, that is the value of speed which is called as N is equal to 666.7 rpm. So this will be the value of the steady state speed, and that will be the required first thing for to calculate the value of the problem. Okay, so the value of N is what? Now it will be called it as 666.7 rpm. So now we call it as N1 because it is a steady state speed. Okay, so that will be the required solution of your first thing. Now we are moving towards the next thing, that is we want to get the value of the speed. when the reversal will takes place. So for the sake of understanding of the reversal of your motor, we can get the steady state speed. Steady state speed for what? When the load torque is passive. So in the given problem, we are having the value of the load torque, that is the passive load torque. So we are having the value of that particular torque. So again we are equating, that is equation, that is steady state Tm is equal to TL, where Tm is called as motor torque and TL is called as the load torque. So we are getting, that is Tm minus TL is equal to 0. So we are having the value of the motor torque for the reversal. So the value of the motor torque for reversal is minus 100 minus zero point 0.1 N minus 0.005 N is equal to 0. So we are getting value, that is minus 100 minus 0.15 N is equal to 0. So we are getting the value, that is obviously minus 0.15 N is equal to that minus 100 will be the plus 100. So if you want to get the value of N, that is called as minus N, or N is equal to 100 divided by the 0.15. So we are getting the value of N, that is N value is positive. This is called as the reversal speed, and the symbol of that particular speed is, now it is minus, so minus 667.7 rpm. So we are getting the value of the speed for that particular thing. So we are getting the value of the speed for that particular thing, that is sine, which is called as minus 666.7 rpm. So this speed is not the final speed, this will be the initial reversal speed of your motor. So reverse speed is very important thing for the sake of the calculation. And now the value of that particular initial reversal speed is what? Minus 666.7 rpm. So this will be the very important thing, and that will be the solution of the initial reversal speed. Then when reversal is done, the motor load torque equation, this will be the fundamental torque equation. So this will be the fundamental torque equation, which is called as the Tm motor torque is equal to load torque plus J into d omega m by dt. So what do you mean by Tm? It is the motor torque, TL it is the load torque, it is J, it is polar moment of inertia, it will be the rate of change of the angular acceleration with respect to time. So we have to substitute the all value in the given thing. So what will be the value of the motor torque when the speed reversal is happen? So it will be the value, that is minus 100 minus zero point 0.1 N is equal to the value of the load torque 0.005 N plus the value of J. So we have the simple calculation for the value of the J. So we have the value of J, that is zero point 0.2 obviously. So the value of J is with us, so we can get the value of J. So we have the value of J, that the value is called as the 10 kg meter square into the rate of change of speed, that is d omega m by dt. So by simple calculation, now we want to find out the value of t. So for sake of that, now we have shifted this term towards that term, means we are getting simple equation in concern with j. So the value of j we are not substituting, keep as it is. So j is equal to d omega m by dt is equal to minus 100 minus zero point 0.1 N minus 0.0. So friends, for the calculation of the J into d omega m by dt, we are taking it as the J into d omega m by dt is equal to minus 100 minus zero point 0.1 N minus 0.005 n Newton meter. So we are getting the term that is minus 100 minus 0.15 n Newton meter. Okay, so this will be the term which is called as J into d omega m by dt. Okay, so this will be the equation for the finding out the value of the t. So we are getting this equation. So after that equation, in the given problem we are having the value of the speed. So if you want to get the conversion of angular velocity into speed, that is omega m is equal to 2 pi n by 60. So 2 by 60, that is pi n by 30, is equal to omega m. Now we can substitute this value of omega m into that equation. So we are getting one equation that is called as dn by dt is equal to this 30 term, 30 divided by this j is converted now up to the bottom side, that is j into value of pi, because this will be the pi kept as it is, in bracket minus 100 minus 0.15 n. So this will be the required thing. Now we want to substitute the value of j. So we are substituting value that is 30 divided by equivalent term. So we are substituting the value of 30, we are substituting the value of j, we are substituting the value of pi. So we will get one important answer, and that answer is called as minus 95.49 minus 0.143 n. So what do I mean by 0.143 n? It will be the value of speed in terms. Okay, so from that particular equation we can get the simple thing. So that the simple thing is, again we want to calculate, that is the dn by dt is equal to minus 95.49 minus 0.143 n. So we want to calculate the value of dt. So for the calculation of dt, we take, that is dn, we are shifting this term towards this and this toward this. So dn divided by minus 95.49 minus 0.143 n. So this will be the equation of your dt. Then the next step is what? We want to finding out the value of the n2. So from the fundamental equations, that is the n2 is called as the final speed of your transient state, and that will be treated as the 95%, means 0.95 into the initial reversal speed. So the initial value of the reversal speed is given by the fundamental equation, that is 666.7 rpm. So we are getting the value of the n2, and the value of the n2 is minus 633.4 rpm, that is minus 633.4 rpm. So this will be the value of the n2. So for the calculation of the t, we will require the value of n1 and we will require the value of n2, because we want to take from the fundamental equation of the calculation of t, we want to get the simple, that is t, that is the time of speed reversal, that is transient time of the speed reversal, is equal to integration of dt. But the value of dt is what? That we had already derived. The value of dt is what? dn divided by minus 95.49 minus 0.143 n. Now we can substitute this value into that equation, so we can get the value of dt. So we have to take the value of n1 and n2. So we are having the value of n1. So what should be the value of the n1? Value of n1 is 666.7 rpm and the value of n2 is 633.4. So now we can substitute this value into that equation, that is n1 to the n2. N1 is called as the initial speed, that is called as steady state speed, and the n2 is called as a final equilibrium speed, that is dn divided by minus 95.49 minus 0.143 n. So this will be the respect to d by, that is dn by n. So we can getting the value in terms of the integration. So now we can substitute this all value of n1 into that equation, that is 666.7 rpm, and n2 minus 633.4 rpm into your calculator, that is scientific calculator. We can get the directly integration of this term, and the integration of this term will give you the value of the time reversal, and this value of time reversal is obviously 25.58. that is the value of the time reversal of your drive, and that will be the required solution of your problem. So that will be the required solution of your problem. So in this way, for the calculation of the time of reversal, first of all we want to find out the value of the speed that is at the steady state, that is n1 at the steady state. Then we want to find out the value of the n2, and for the sake of the n2 we can take directly, that is 0.95 into the initial value of the reversal speed. So we can get the value of n1, we can get the value of n2. So if we are getting the value of n1 and n2, then we have the fundamental formula of calculation of t, that is integration of dt. So integration of dt is basically in concern with the n1 to the n2. So now we can substitute the value of n1 into n2 and the value of the data into that equation. We will get the value of the time of reversal in terms of the second. So in that particular problem, the value of the time of reversal is 25.58 second. Thank you.